6 days. That is how long it is going to take. 6 days from the moment the United Kingdom stood at 34.8 degrees Celsius, a temperature so extreme that it shattered every spring, and may record to the moment that weather maps covering the same country turn icy blue and forecasters begin issuing warnings about frost, not a gradual easing. Not a gentle return to seasonal norms over a comfortable stretch of transition. A near vertical collapse in the atmospheric system that delivered the heat, replaced by something arriving so cold, so wet, and so completely the opposite of what this country has been experiencing that the maps used to display it have shifted to the coldest end of the color spectrum. The icy blue that is now spreading across forecast charts for Scotland and northern England in the first days of June 2026 represents temperatures that could touch 2 degrees Celsius overnight, with frost returning to elevated areas and a temperature gap between the peak of the bank holiday heat wave and the bottom of the coming cold spell that may exceed 30 degrees across some parts of the country. 30 degrees of temperature swing in less than a week, in the same country, in the same month. This is what the British climate looks like in the age of extremes. The record that stands at the center of this story was set at Kew Gardens in southwest London on Monday, the 26th of May, 2026. The Met Office confirmed in an official statement that 34.8 degrees Celsius had been provisionally recorded at that location, making it the highest temperature ever measured during meteorological spring in the United Kingdom and the highest May temperature in the entire record, which stretches back well over a century. The previous record had stood at 32.8 degrees Celsius, set in 1922, and had remained unbroken through every warm May, every early summer surge, and every African plume event that had reached the British Isles in the 104 years that followed. It was not broken on the 26th of May, 2026. It was demolished. The margin of 2 degrees Celsius, by which the new figure exceeds the old record, is not a marginal adjustment to a long-standing number. In the context of temperature records, for a specific month in a temperate maritime climate, it is a seismic leap, the kind of margin that meteorologists and climate scientists describe as extraordinary, and which signals not just a weather event, but a crossing of a threshold that reshapes expectations about what the British climate is capable of. The week leading into that record had already been delivering temperatures of extraordinary significance. Temperatures climbed above 28 degrees Celsius on Friday, the 23rd of May, seasonal event. Monday arrived, and the heat intensified further still, with the convergence of a perfectly positioned high-pressure system, a southerly wind drawing air from the heated continental interior of Europe and the Sahara beyond, and the adiabatic warming that occurs as that air descends toward the British surface, all combining to deliver the 34.8 degree reading at Kew, and temperatures above 30 degrees across a broad swathe of central, southern, and eastern England. The Met Office confirmed that the heat was expected to continue into Tuesday, the 27th of May, with a peak of 35 degrees, again expected in London, the home counties, and Cambridgeshire. Temperatures exceeding 30 degrees were forecast to reach across eastern Wales and large areas of central and eastern England, away from immediate coastal zones. Beyond Tuesday, the forecasts showed a gradual retreat, with 33 degrees on Wednesday, 32 on Thursday, 30 on Friday, and 29 on Saturday, before the atmosphere underwent its sharp and dramatic transition. The mechanism that is ending this extraordinary heat wave and replacing it with the cold spell now turning the weather maps blue is the re-establishment of the Atlantic southerly flow that drove heat into Britain from the African continent, is beginning to weaken and shift. Into the gap created by that weakening, the Atlantic jet stream is beginning to reassert itself. The jet stream is the high-altitude river of fast-moving air that encircles the northern hemisphere and whose position and strength are the primary strengthens directly over or north of the British Isles. It begins to steer Atlantic low-pressure systems toward the UK with increasing frequency and intensity. What is currently developing in the North Atlantic is precisely that pattern. A strong low-pressure system, energized by the sharp temperature contrast between the anomalously warm air sitting over Britain and the much colder air mass sitting over Canada and the far North Atlantic, is beginning to organize and track toward the British Isles. The Met Office's deep dive analysis of the developing situation has highlighted that by Friday into the weekend following the bank holiday heat peak, another area of low, is expected to remain to the northwest of the UK initially, but will bring progressively more unsettled conditions across Northern Ireland, Scotland, and the western areas of Britain, with showers, spells of rain, and brisk winds becoming increasingly prevalent before spreading further into England as the week progresses. Deserves specific attention. When a cold front advances into an air mass that has been heated to the level seen across Britain during this bank holiday event, the clash of air. Masses at the frontal boundary generates intense atmospheric instability. Warm, moist, buoyant air near the surface is undercut by the denser advancing cold air. forcing the warm air to rise rapidly and cool, which releases enormous amounts of latent heat energy into the atmosphere and creates the conditions for powerful convective development. In practical terms, periods hail and lightning. The combination of parched, rain-starved ground across much of central and southern England following the driest period of the bank holiday week with the speed of the transition is the element that makes this shift so striking and so practically significant for the millions of people who will live through it. Meteorologists describe the kind of atmospheric reversal now unfolding as a cold front breakdown, a term that captures the mechanism by which the air mass supporting the heat is undercut and replaced by a colder, wetter, Atlantic-sourced air mass in a matter of hours rather than days. When a cold front sweeps across Britain, the temperature change it delivers is not gradual. On one side of the frontal boundary, warm air continues to flow. On the other side, which advances across the country from northwest to southeast, the temperature drops sharply within the space of a few hours. Cities and towns that experience the frontal passage will record a temperature fall of 8, 10, or even 12 degrees Celsius within the span of an afternoon, passing through conditions that feel like an entirely different season without any intermediate stage between summer and autumn. Scotland will be the first part of the UK to feel the cold air arrive, and the forecasts for the Scottish Highlands and other elevated areas are the ones turning the most dramatically icy. Blue on the weather maps. Temperatures in northern Scotland that were sitting in the low 20s during the height of the bank holiday warmth are expected to fall towards single figures within days, with overnight minimums in elevated inland areas potentially approaching 2 degrees Celsius by the first days of June. The potential for frost has been explicitly noted in the Met Office extended outlook, with the advice that gardeners should be mindful of this shift following the warm conditions, because the combination of clear skies that often accompany the trailing edge of a cold front and the rapid overnight temperature drops associated with cold northerly air masses creates exactly the conditions under which ground frost occurs even at low elevations. A country that was issuing amber heat health alerts for a bank holiday temperature of 34.8 degrees will, within approximately 6 days, be issuing frost warnings for overnight lows in the low single figures. That is the full span of what the British climate is capable of delivering within a single week in late May and early June 2026. There is something worth pausing on in the specific geographies of where the 34.8 degree record was set, because it speaks directly to the physical mechanisms that made this event so extreme. Kew Gardens sits in southwest London at an elevation of just 5 meters above sea level. It is embedded within the urban fabric of Greater London, which means it benefits from the urban heat island effect that sees dense cities retain and radiate significantly more heat than the surrounding countryside. But Kew is not the only location that registered extraordinary readings during the bank holiday heat wave. Stations across a broad arc of southeast England, from Cambridgeshire to Kent to Sussex to Berkshire, were all recording temperatures above 32 and 33 degrees Celsius during the peak of the event. What Kew provided was the specific combination of urban heat island enhancement, optimal geographic positioning relative to the southerly airflow, and sufficient shelter from any coastal moderating influence to push its reading to the highest figure of all. The fact that it is also one of the longest-running observation sites in Britain, with continuous records since 1876, means that the record it has set is directly comparable to the entire history of British weather observation in a way that a reading from a newly installed station would not be. When the Met Office states that 34.8 degrees is the highest May temperature in the UK record, it means the highest reading in a continuous series stretching back nearly 150 years. That is the weight that the number carries. The contrast between these two extremes contains a story that goes beyond the immediate weather and into the deeper dynamics of a climate system that is becoming more volatile in ways that the familiar language of seasons and averages is struggling to describe. The traditional British understanding of late May and early June as a period of gradually warming, increasingly settled weather, the stretch between the late frosts of spring and the reliable warmth of midsummer is being disrupted by the increasing frequency and severity of atmospheric blocking events and their subsequent breakdowns. An atmospheric block is the meteorological term for what produced the heat wave, a persistent high-pressure system that locks in place and prevents the Atlantic westerlies from reaching Britain for an extended period. When that block eventually breaks down, as all blocks eventually must, the suppressed Atlantic flow often returns with a force proportional to how long and how completely it was held back. The stronger and longer the block, the sharper and more dramatic the cold breakdown that follows it. This pattern of blocking, followed by violent atmospheric reversal, is becoming more pronounced in the UK climate record as the planet warms, and the scientific understanding of why connects directly to the same climate dynamics that are producing record heat waves. The rapid warming of the Arctic relative to the tropics and mid-latitudes is reducing the temperature gradient that gives the jet stream its strength and coherence. A weaker, more meandering jet stream is one that blocks more frequently, allowing heat to build further in the warm sector and cold air to penetrate further south in the cold sector before the eventual breakdown. What is being observed across Europe and the UK in recent years, a pattern of more extreme heat events interspersed with sharper cold reversals, is consistent with what climate scientists predicted would happen as the meridional temperature gradient of the northern hemisphere was disrupted by Arctic amplification. The icy blue maps of early June 2026 are not separate from the record-shattering heat maps of late May 2026. They are the same story, told in a different color. The agricultural implications of this kind of late-season temperature swing are significant and largely underappreciated in mainstream weather coverage. May and early June are critical periods for a wide range of crops across the UK, including soft fruit, salad crops, early potatoes, and a variety of vegetable crops that were either planted outdoors during the warm spell or that have been developing in glasshouse or polytunnel conditions and are approaching the stage at which outdoor transplanting becomes possible. Growers who were encouraged by the exceptional warmth of the bank holiday heat wave, which will have advanced growing degree day accumulations by weeks compared to a typical late May, now face the prospect of overnight temperatures approaching or touching frost level in the days that follow. Soft fruit, such as strawberries and raspberries, which are in active flower or early fruiting stage across many parts of Britain at this time of year, are highly sensitive to frost damage on the flower or fruitlet, and even a light frost lasting a few hours can destroy a significant proportion of the yield in an unprotected crop. While measured in tone, is a warning that anyone with there is a human physiology dimension to this rapid temperature swing that receives almost no coverage in weather reporting, but which has real implications for health and well-being. The body's thermoregulatory system does not flip instantly from heat mode to cold mode. After several days of sustained heat exposure, the body has made a series of physiological adjustments oriented toward cooling. The sweating threshold is lowered. These are adaptations that help the body survive heat, but which make it temporarily less efficient at retaining warmth when temperatures fall rapidly. People who have spent the bank holiday week in extraordinary heat and who enter the sharp cold of the Atlantic air mass without adequate clothing or shelter are at genuine risk of cold stress in a way that the body that has been losing fluid and electrolytes through days of sweating, and which has its peripheral blood vessels in a vasodilated state oriented toward cooling, is not in an optimal position to suddenly manage a drop to single-figure overnight temperatures. Wrapping up warmly, maintaining fluid and food intake, and being aware of this transitional vulnerability is sound advice for anyone moving from the record heat of May into the cold first days of June 2026. To near frost conditions within a single week creates practical challenges that are easy to underestimate. The NHS, which mobilized its heat health response protocols during the bank holiday heat wave and directed clinical resources toward the management of heat-related illness, will within days face the resurgence of cold-related health pressures that are, in their own way, as demanding on health service capacity as extreme heat. Respiratory conditions worsen in cold, damp weather. Slip and fall injuries increase when rain follows an extended dry period and coats roads and pavements with the first rain-slicked surface in over a week. People who were sleeping with windows fully open during the tropical night phase of the heat wave will transition abruptly to conditions where open windows at night produce rapid chilling of rooms that have been warmed by days of accumulated heat, creating the risk of cold-related illness for the elderly and those in poor health. The temperature swing is not just a curiosity for weather enthusiasts. It is an event with real consequences for health, carries a particular historical significance in the context of both the heat record and the cold transition that follows it. The Royal Botanic Gardens at Kew is one of the longest-running and most respected meteorological observation sites in the United Kingdom, with a temperature record stretching back continuously to 1876, and a reputation for measurement standards that make it one of the reference points for comparative historical temperature analysis in the British Isles. The reading of 34.8 degrees registered there on the 26th of May 2026 therefore sits in a data series that encompasses nearly 150 years of daily temperature observations, and its significance as a record within that series is absolute. Every warm May since 1876, every African plume event, none of them produced a May reading of this magnitude before the 26th of May 2026. When the temperature at Kew falls to single figures in the nights ahead, that too will be recorded in the same continuous series, adding another chapter to the story of a year that has already begun to look like one of the most climatically remarkable in the recorded history of British weather. The significance of more than half of the UK's monthly temperature records having been set since 2003 should be allowed to land without deflection. The Met Office confirmed alongside the 34.8 degree announcement that if the May 2026 figure is confirmed and validated, It will mean that 7 out of 12 monthly records across the entire year will have been set in the 23 years since 2003, compared to the preceding 119 years of comprehensive records. That is not a distribution that reflects random natural variability. It is a distribution that reflects a climate system being pushed systematically toward higher temperature extremes at a rate that has no historical precedent in the instrumental record. The record temperatures and the icy blue maps that follow them within the same week are both expressions of that same underlying shift. The swing is not a contradiction of the warming trend. It is one of its most visible and least well understood consequences. Weather maps of Britain, the country is left to process the full arc of what this final week of May 2026 has delivered, a spring temperature record that had stood since 1922, a tropical night in a month that had never produced one before, record-shattering heat in 10 counties simultaneously, and the British climate has once again demonstrated, in the most vivid and unarguable terms possible,